Hi everyone, welcome to another tutorial of linear algebra. In this lesson, this will be applying Gaussian method, but we'll be using it in practical situation. What do you mean by practical situations? It means in situations where the questions are not direct. Like examples, they want you to determine like for the first question, they want you to determine what are the values of k in which there are no solutions, many solutions, or a unique solution. Like for the past two videos, we are actually been told to find what is the solution of the system. So for this case, we want to determine what values of k in which there are no solutions, many solutions, or a unique solution. So what's our first step again? We notice that the two rows have x variable, so we want to eliminate one of the x variable. So we add 3 times for row 1 to row 2. So the left hand side will go as this and the right hand side will go as this. So left hand side, same thing, minus 3 times x minus y plus 3x minus 3y equals to minus 3x plus 3y plus 3x minus 3y will give me 0. And the right hand side will go to k minus 3. So this is my equation here. So you notice we get into this form. So now, for what value of k in which there are no solution? So to be no solution, the one of the equation must be inconsistent, not logical and not consistent. So for the second one, we focus on 0 equals to k minus 3. As you can see, to have no solutions, 0 cannot be equals to 0, which in other words, k minus 3 cannot be equals to 0. So hence we say that 0 is not equals to k minus 3. Hence we put as k is not equals to 3. And to have a many solution, one of the variable and 0 equals to 0, which means 0 equals to k minus 3, hence k equals to 3. So if we were to sub in 0 equals to 0, y will not be the leading variable, and hence the system will have many solutions since the system has at least one variable which is not a leading variable. And to have a unique solution, there is no value of k to fit this description. So now let's go to the second part. We have a second question here. This question is not direct. Like the system, like for this question, it was given that the system is not linear in some sense. Like we have 2 sine theta minus cosine beta plus 3 tangent theta, etc. and follow for the second and third row. So what do? We assume, we assume that this will be a linear. So what do? We substitute. So we let sine theta be x, cosine beta be y, and tangent L equals to z. So we get this form. 2x minus y plus 3z and 4x plus 2y minus 2z and 6x plus 3y plus z. So what do? You want to eliminate the x variable on the first and second row. So by look at the x variable, they're all in ascending order. That will be easier, so we don't need to swap any of the rows, since that for the x variable is all the coefficients are in ascending order. Hence we can add minus 2 times of row 1 to row 2 to eliminate the x variable on the second row, and add minus 3 times of row 1 to row 3 to eliminate the x variable on the third row. Hence you can see, for adding minus 2 times of row 1 to row 2, we get minus 2 and etc. We get 4y minus xz, and right hand side is 4. And hence for the adding minus 3 times of row 1 to row 3, left hand side goes as this, the right hand side will go as this. Hence this will be our equation in the end. Hence we can solve the equation. Hence this will be our equation, and hence we can solve it to get the value of alpha, beta, and lambda. So now for our next question. It is also not straightforward. So what conditions must constants be satisfied so that each of these systems have a solution? So for this, we are given as this. So what do we do next? Since the coefficient of x are in ascending order, we can therefore do the first step, where as you can see, we are given these systems or equations. So what do? We sort the coefficient of x. We sort the rows in according to ascending orders of the coefficients of x. So hence, first step, we swap row 2 with row 3. We get this. But for the 3x and 2x, we swap again to get this. So now it's easier to solve. So what do? We add minus 1 times of row 1 to row 2 and add minus 2 times of row 1 to row 3 and add minus 3 times of row 1 to row 4 to eliminate the x variables in the second to fourth row. So this will be a 3-step at the same time. So we get as this. So these are the details of how we go through the things. So hence, after this, what do? Fourth step, you want to eliminate the y variables in the third and fourth row. So add minus 1 times of row 2 to row 3 and minus 1 times of row 2 to row 4. Hence, we get this. However, after reducing, we get in this kind of form. So what do we do next? To have a solution, it must be logical, must be consistent. So hence 0 equals to 0 and 0 equals to 0 for the third and fourth row. Which in other words, b2 minus b1 minus b3 equals to 0 and b4 minus b1 minus b3 equals to 0. And this is what the solution of b has to be in order for it to be a solution. Let's take a look at another example, which is this. So, first steps first, we notice that the x are still not in ascending order for the coefficient of x. So what do? We swap row 2 with row 3 and hence we get this. So now our job is easier. So we add minus 1 times of row 1 to row 2 and minus 2 times of row 1 to row 3 to eliminate the x variables in the second and third row. Hence this is what we get. And the workings are all shown on the right hand side over there, as you can see. I will not go into detail. However, we look for the x2 coefficient, we notice that the third row has a lower coefficient than the second row. So what do? We swap row 2 with row 3, hence we get this. So now what do? We can eliminate the x2 variable in the third row. So hence, we add 2 times of row 2 to row 3, hence we get this form. So now we can easily work our way out. So to have a solution, x3 must be equals to this. For row 3, x3 equals to this. And for x2 to have a solution, so now this is our value for x3. And now for x2 to have a solution, we plug it into row 2. So we sub in x2 minus 3 bracket 5b1 minus 2b2 minus b3 equals to b2 minus 2b1. After manipulation, we get x2 equals to this here. And now, for finding the coefficient of x1, we plug into the first row and we get this. So after manipulation, we must make sure that x1 equals to this value. So this will ensure that the system has a unique solution. And now let's look at The last question. So now show that if AD minus BC equals to 0, then these systems will have a unique solution. So first things first, we assume that A is a lower coefficient than C. So what do? We add minus C over A times our rho 1 to rho 2. Hence we get this. And now, after we manipulate, we get this form. However, you notice, we are given this form, AD minus BC equals to 0, and this. So hence, we manipulate. So if AD minus BC equals to 0, hence AD minus BC over A is not equal to 0. Hence, since both variables x and y are leading variables, and everyone has a leading variable, and the system is in echelon form, therefore it has a unique solution. Yes, it's all about. So I guess this lecture is not very direct.